All right, here we go. Question 29 from our Calculus 1, homework number 3 in WebAssign. They want us to find the equations of the tangent lines to the curve where they've given me a rational function that are parallel to the line x minus 2y equals 2. And it says enter your answers as a comma-separated list. That means if there's more than one line, we need to put them in separated by a comma. So going to my scratch work, the first thing we know is that our tangent lines have to be parallel to this line. And we know that lines that are parallel have the same slope. And so then that means that I need to put my equation in slope-intercept form. Step number 1, we're going to move the x to the other side. That'll make that negative x plus 2. And then divide everybody by negative 2 to get the y by itself. And so we can see that that's going to give us a slope of positive half. And I don't really care about the y-intercept. This is all I care about, what the slope of the line is. Now notice that what that means is it means that the slope of the tangent line must also be a half. And how do we find the slope of the tangent? Well, we take the derivative. So we're going to find y prime, set it equal to a half, and what that'll give me are the x coordinates of the points where the tangent line touches the curve. All right, I've cleaned my workspace up a bit. Here we've got the slope that we're shooting for. We're ready to find the derivative. And since we have a fraction, we're going to have to incorporate the quotient rule. Taking the derivative of the top is going to give us just 1 because the derivative of the constant goes to 0 and the derivative of x is just 1. So there's the derivative of the top times the bottom minus the top times the derivative of the bottom. Again, in the denominator, the derivative of the constant goes to 0, and the derivative of x is just 1. All over the denominator squared. And then we need to clean this up a bit. So we know that 1 times anything is itself. So I'm going to be left with x plus 1. And then this negative is going to need to distribute and change the signs. So we'll have x plus 1 minus x plus 1 all over x plus 1 quantity squared. And in the numerator, my x's are going to subtract out and make 0. And that's going to leave us with the derivative of 2 over x plus 1 quantity squared. But remember that we need that derivative to be equal to a half. And so we're going to set up this equation and solve for x. Notice that this is a proportion, so I can cross multiply, and that's going to give me x plus 1 squared equal to 4. Taking the square root of both sides to get rid of the squared leaves me x plus 1. Square root of 4 is 2, but since I took the square root of both sides, I do need a plus and a minus. And the last step says that we're going to bring that plus 1 over, which will make that a negative 1 plus or minus 2. And simplifying here, we're going to get x equals negative 1 plus 2, which is 1, negative 1 minus 2, which is negative 3. And then I need to find the y coordinates that correspond to these x coordinates. The way we're going to do that is we have to plug these x's back into the original function, which was y equals x minus 1 over x plus 1. Substituting 1 in, we're going to get 1 minus 1 over 1 plus 1. 0 over anything is 0, and so there's my first ordered pair. And then if I go back and replace the x's with negative 3, we're going to get negative 4 over negative 2. Negative 4 over negative 2 is 2, and that gives me my other ordered pair, which is negative 3, 2. And so recall that the slope had to be a half, and now that I know a point and the slope, I can write the equation of these lines using the point-slope form. Here we go, y minus y1 equals m, x minus x1, and y minus y1 equals m, x minus x1. Minus a negative makes that a plus. And simplifying, for the first equation, y minus 0 is just y, and the 1/2 needs to distribute. 1/2 x minus a half. Now for the other equation, it's going to be a little bit more work. Here the -2 has to move over, and we're going to distribute, giving us y equals 1/2 x. 1/2 times 3 is 3/2. The -2 becomes +2, and I need to add these like terms. So that's going to be 1/2 x plus, that's 1/2 plus 2, which is 3/2, which is 7/2. And that gives us the equations of our tangent lines. And so now all we need to do is input those into our WebAssign. I don't know if you noticed, but you can see there's a red X here. I actually screwed up on my first attempt, and so this is my second attempt at trying to get the answers here. And on a side note, just for fun, I know I like to show Desmos. Let's look again at how Desmos can verify that what we got is correct. We can see that our tangent lines that we came up with do intersect the graph at -3, 2, and at 1, 2. We can see that those are tangent and they look parallel, but are they parallel to the given line? Well, we can graph that as well and see if it is parallel. The equation of the line they gave me was x minus 2y equals 2. And we can see again that all three of those lines appear to be parallel. So that kind of helps give us a visual representation of what's going on, but it also helps us to feel better about our solution. And inspecting what I've input into WebAssign, I've got my y equals 1/2 x minus a half, comma to separate the other answer, y equals 1/2 x plus 7/2. And I did put a space after the comma. I'm not sure if it's going to like that or not. It may not matter, but we're going to click submit and see how we did. And we did get the green check of success this time. So that's going to do it for this problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.